For generations, scientists believed that the universe's earliest history would remain forever beyond our reach. The first stars, the earliest giant star clusters, and the birth of the first galaxies all unfolded billions of years ago, hidden behind immense distances and the limits of human observation. Although computer models offered predictions about how those ancient cosmic structures formed, direct evidence was frustratingly scarce. The universe's opening chapters seemed destined to remain largely theoretical. Everything began to change with the launch of the James Webb Space Telescope. Equipped with the most advanced infrared observatory ever built, Webb has given astronomers the ability to look deeper into space, and therefore farther back in time, than ever before. Light that has traveled for billions of years is finally reaching instruments sensitive enough to capture it. As a result, galaxies that once appeared as faint smudges are now revealing remarkable details about the universe's distant past. Among Webb's most fascinating observations is an unusual galaxy known as the Spark Galaxy. Because of its incredible distance, the galaxy is seen as it existed roughly 9 billion years ago, during an era when galaxies across the cosmos were still actively growing and assembling their stellar populations. Surrounding this distorted galaxy, astronomers identified several tiny but unusually bright sources that appear to be ancient globular clusters, compact collections containing hundreds of thousands, and sometimes millions, of tightly packed stars. These objects are not believed to be the universe's very first stars. However, they may belong to some of the earliest generations of massive stellar systems that emerged soon after the first major wave of star formation. Rather than simply observing distant points of light, Webb has uncovered preserved snapshots from an era that has remained largely inaccessible throughout the history of astronomy. Each observation provides another opportunity to understand how the young universe gradually transformed from a relatively simple environment into the richly structured cosmos we see today. Globular clusters have always fascinated astronomers because they are among the oldest surviving stellar systems known to exist. Unlike loose groups of stars that slowly drift apart over time, globular clusters remain tightly bound by gravity for billions of years. Their dense populations can contain anywhere from several 100,000 to well over 1 million stars, all orbiting together in a remarkably stable configuration. Within our own Milky Way, many globular clusters are estimated to be more than 10 billion years old. Their great age makes them invaluable cosmic archives, preserving information about the physical conditions that existed when galaxies were still in their infancy. By studying these ancient stellar cities, scientists gain clues about the earliest stages of galactic evolution. Until recently, however, observing globular clusters at extreme distances presented an enormous challenge. Powerful telescopes could study nearby clusters in impressive detail, but objects located billions of light-years away remained little more than faint points with almost no measurable characteristics. Their true nature remained hidden behind the limitations of previous generations of instruments. James Webb dramatically changed that picture. Its extraordinary infrared sensitivity, combined with exceptionally sharp imaging capabilities, allows researchers to examine distant stellar systems with a level of precision that was previously impossible. By analyzing the brightness, color distribution, and chemical fingerprints of the compact objects surrounding the Spark Galaxy, scientists discovered that several of them possess characteristics expected from mature globular clusters rather than newly forming stellar nurseries. This finding is especially important because it allows astronomers to study these massive stellar systems much closer to the period in which they originally formed instead of examining only their much older descendants. It's similar to observing an ancient civilization while it is still being built rather than trying to reconstruct its history thousands of years after it disappeared. The Spark Galaxy itself became a particularly valuable target because its unusual appearance results from one of the most fascinating predictions of Einstein's general theory of relativity, gravitational lensing. According to Einstein's theory, massive objects warp the fabric of spacetime. As light travels through these distorted regions of space, its path bends under the influence of gravity. When an enormous galaxy cluster lies between Earth and an even more distant galaxy, it acts like a natural cosmic magnifying glass, bending and amplifying the background light. In this remarkable case, a massive galaxy cluster known as SMACS 0723 served as that natural lens. Its tremendous gravitational field stretched and magnified the light coming from the spark galaxy, allowing James Webb to detect structures that otherwise would have remained far beyond our observational capabilities.